Hello, my amazing students. This is Mrs. A, and I am starting 8.2, which is about hypothesis testing of a population proportion. All right, so as we start talking about population proportions, testing a claim about a population proportion, we're going to be doing this very similarly to Chapter 7. I told you that Chapter 8 was going to be all a big clump together, just like Chapter 7 was. And remember, in Chapter 7, we did basic, just an intro on what a confidence interval was, and then we talked about testing a claim about a proportion, estimating a proportion and estimating a mean. And when we got to means, we talked about both small sample size and large sample size. We're going to do the exact same thing with the hypothesis testing. It's going to follow the same type of pattern. So, the key concept here, section describes a complete procedure for testing a claim about a population proportion P. We illustrate hypothesis testing with the p-value method, the critical value method, and the use of confidence intervals. So when you're looking at this, we're going to say, okay, p-value, critical value, method. These are two different methods for making the decision on the hypothesis test. There are different methods for testing a claim about a population proportion. Part 1 of this section is based on the use of a normal approximation to a binomial distribution, and this method serves well as an introduction to basic concepts, but is not a method used by professional statisticians. Part 2 discusses other methods that might require the use of technology. So we're going to discuss these. The ones that we're going to use mostly are going to be the z-score, and we're going to do that both with the p-value and the critical value. We're not going to worry too much about the confidence intervals, but I'll tell you as we get there what we're going to really concentrate on. So this is our basic layout here. This is kind of the cheat sheet that I like to set up for you. Our little steps 1 through 3 state the claim mathematically and verbally, identify the null and alternative hypotheses, test the statistics is sample proportion. The test statistic is the sample proportion. We're going to state our H sub O and our H sub A. These should all sound familiar if you listen to 8.1. These up here, remember, our proportion is the binomial, and these make sure that we have met the qualifications for having a large enough sample size to do the hypothesis test to start with. Specify the level of significance is number 4. Identify the test statistic and the distribution is step 5. Because proportions, remember in 7.1, we used the standard normal for proportions. We're also going to do that. Once we meet these, we can treat it as a standard normal distribution. Okay, so then 6 is find the standardized test statistic and sketch the sampling distribution, and then make a decision to reject or fail to reject the null hypothesis, and then interpret the decision in the context of the original claim. So that is the layout of what we're going to be doing over and over and over again. This is an example of a hypothesis test for proportions. A research center claims that less than 50% of U.S. adults have accessed the internet over a wireless network with a laptop computer. I'm sorry, I'm getting kind of gravelly. I think I got a cold. When you're hanging out with 13 grandchildren, you're probably going to get something, so I guess a cold is the least of my worries here. But in a random sample of 100 adults, 39 say they have accessed the internet over a wireless network with a laptop computer. Now, hopefully you can tell that this is a example that I got quite some time ago, because I would imagine that almost every adult in the U.S. has done that. But this was quite a few years ago that this example came across, and it's a good example even though it's a little outdated. At alpha is 1%, is there enough evidence to support the researcher's claim? So I said, you can tell these slides are old. So we verify first that NP is greater than or equal to. So here, when we verify these, then we can use the standard normal distribution. So we have to verify that we have a large enough sample N to be able to use the standard normal. So we have to meet our qualifications, and here we do, because it has to be greater than 5 and it's 50. Then we start to fill in. Notice what we're looking for. Here it says claims that less than 50%. Okay, so 50% would be 0.5. So we're going to say here our H sub A is going to end up being our claim. Okay, now I don't know where it says it, but okay, we didn't say it, but the H sub A is the claim. I should have had that written there. The H sub O is going to be the complement of the H sub A. We're doing this to the 1% alpha. So then we have 1% is to the left in the little tail. So then to find that critical value, we can look up 1% in our standard normal table. Right, so now when I go to my standard normal table here, and I'm going to look up 0.01, because this is 0.01 to the left. So I'm looking at this area over here, and I want it to be 0.01 because of the 1% alpha. And since it's a left-tailed test, the alpha will be in one tail. So I'm going to have 0.01, and when I look at it, it's going to be right there. Okay, so that is 0.0099, and this is 0.0102. So this is 2 steps away. This is 1 step away, so I'm going to go with this one. So when I go over to the left, I get negative 2.3, but then when I go straight up, I get a 0.03. So negative 2.33. And that is what they have on the screen. So 1% is the alpha. It is the area that is going to be to the left, since this is a left-tailed test. Okay, again, you should have hopefully learned when we use left-tailed, right-tailed from 8.1. So now here is my critical value, negative 2.33. It is the z-score that separates my rejection region from the rest of my curve. And when I go to my own test statistic, boy, I'm having a hard time tonight. I have my p hat minus my p divided by the square root of pq over n. Now remember, if I'm going to let the 0.5, p is less than 0.5, 0.5 is my decision point there. So I'm going to have 0.5, 0.5, and divided by 100, the square root of that, and then the 0.39 was the p hat, the sample proportion, and the 0.5 is the true proportion that I'm going to use. When I do all of that math, I get a negative 2.2. And then I try to figure out where is negative 2.2. Well, negative 2.2 is not in the rejection region. Let's go a little closer here. Remember, the rejection region starts at negative 2.33. Negative 2.2 is on this side. It's on the right side. It's in the normal range. It's not in the rejection region. So I fail to reject H sub O. At the 1% level of significance, there is not enough evidence to support the claim that less than 50% of U.S. adults have accessed the internet over a wireless network with a laptop computer. Okay, so that was our first example. So let's look at another one. A research center claims that 25% of college graduates think a college degree is not worth the cost. You decide to test this claim and ask a random sample of 200 college graduates whether they think a college degree is not worth the cost. Of those surveyed, 21% reply yes. At alpha is 0.1 or 10%. Is there enough evidence to reject the claim? All right, so now we've got 25%. The claim is that 25% of college graduates think a college degree is not worth the cost. Okay, so that is the claim. So let's see what we have. We've got, of those surveyed, 21% reply yes. They do not think that the college degree is worth the cost. Okay, so this would be your p hat, and this would be the p that you're testing here. Okay, so we're going to verify, first of all, that we can use the standard normal distribution because this is binomial, but it meets the qualifications here because we get a 50 and a 150. So now we start looking at the parts here. We're trying to figure out whether, notice that it says it claims that 25% of college graduates think. It's not less than 25%, it's not more than 25%. Basically, they're saying that the percentage of college graduates is 25%. So this isn't equal to 25%. Therefore, remember your H sub O will always be your equal. Your H sub A will always be your inequality. And together, they make up every option you have. Your alpha here is going to be 0.10. And then your rejection region, we're going to have to, since this is a two-tailed test, when we have a not equal, it's a two-tailed test. And we're going to have to split this to go into each region. So we're going to have 0.05 over here and 0.05 over here. So we can go to our table again. We can look up our common critical values. Remember, our confidence level was two-tailed also. So 90% confidence level has an alpha of 0.1, which is what we have. So 1.645 and negative 1.645 should be our values. If we go to our chart, we can see 0.0495, 0.0505, and our desired left tail is right between them. And if we moved all the way to the left, we'd get negative 1.6. And then we'd go back up here to the little dot, go all the way up, and we would get 0.04, but then halfway through 0.045. So negative 1.645, which is exactly what the slide is saying. So basically we have the 0.10, it's being split up in the 0.05 on each side, and then I look up on the z-score chart the 0.05 in the body of the z-score chart, and I get negative 1.645. Okay, so now we come over here, since we know our critical value, we're going to look at our test statistic, which is going to be our p hat minus our p, and then our square root down here. We've got the 0.21, which is the p hat, minus the 0.25, which is the claim, and then we've got the 0.25 matched with its complement q, is 0.75, all divided by n. There were 200 college students tested, and then we take the square root. Once we calculate all of that, we get negative 1.31. We come over here and we plug in a negative 1.31, but it is not in our rejection region. Our rejection region starts at negative 1.645. So again, we fail to reject H sub O. At the 10% level of significance, there is not enough evidence to reject the claim that 25% of college graduates think a college degree is not worth the cost. So here we go with the procedure again. This is out of your book. The one that I've already given you is equivalent to that, but we'll just talk about it a little bit from your book's perspective here. We're going to conduct a formal hypothesis test of a claim about a population proportion. That is our objective. And N is the number of sample trials, P is the population proportion, the P hat is the X over the N, and the Q is the 1 minus P. So we've got all of these different vocabulary things that we should know. The requirements, you've seen these before. These are the exact same requirements that you saw in 7.1. Okay, so no difference. These were the same ones you saw in 7.1. And there is our test statistic, how we calculate the z-score. P-values are automatically provided by technology. If technology is not available, use your standard normal distribution. Your p-value is going to be the percentage that is in the tail. Okay, the critical value is the z-score that starts the tail. Now, the equivalent methods where they're talking about confidence intervals, we're not going to get real into the confidence level method here because we just have a little bit of time. We've got a lot to master. I'm not going to worry about confidence levels, intervals very much, but when testing claims about proportions, the confidence interval method is not equivalent to the p-value and the critical value methods. So the confidence interval method could result in a different conclusion. Both the p-value method and the critical value method use the same standard deviation based on the claimed proportion p. So they are equivalent to each other, but the confidence interval method uses an estimated standard deviation based on the sample proportion. So it says use the confidence interval to estimate a population proportion, which we did in 7.1, but use the p-value method or the critical value method for testing a claim about a proportion. Okay? So here we're talking about the drone deliveries again. 1,009 consumers were asked if they were comfortable with having drones deliver their purchases. And 54%, so if I take 54% of 1,009, I get 545 of them responded with no. Use these results to test the claim that most consumers are uncomfortable with drone deliveries. We interpret most to mean more than half or greater than 0.5. So first of all, we're going to check our requirements. Are our consumers randomly selected? There are a fixed number of trials that are independent, and we looked at our NP is greater than 5 and our NQ is greater than 5, and all is in order. All three requirements are satisfied. So then they're showing us how to go to technology. Now remember, in our 7.1, we use something called prop z int for the interval on the proportion, but now we're going to use prop z test. And when we do that, Okay, so let's go down to my calculator here, and we're going to do stat, and we're going to hit the test. We're going to go to test. We did not hit anything else. Stat, test. And now we're going to go down to prop Z test, and we're going to hit enter. And notice that it's got, now this is what I just put into it. We're going to say our P is 0.5 because that's what we're testing. 545 was my number of people that said they did not like drones. And then 1009 was my N. And then I have to choose which one of these situations I'm looking for. Is the proportion not equal to 0.5? Is it less than 0.5? Is it greater than 0.5? It's always going to be the H sub A that I'm testing there. And then I come down here and I hit calculate. And when I hit calculate, I get exactly what they have up here on our screen. So here they're saying that the computer programs and calculators usually will provide the p-value, and so the p-value is used very often because the technology sources are going to give us the p-value. And here notice that they give us the z is 2.549, and they give us the p-value, which is 0.00538. Okay, so then it says if technology is not available, see the figure 8.1 on page 360, find the value of the test statistic and the p-value, draw a graph and show the test statistic and the p-value. So here, let's go look at that chart on page 360. Okay, so they're telling us how to use the p-value, find the value of the test statistic and the p-value, and then we're going to go to 8.3, figure 8.3. It says draw a graph and show the test statistic and the p-value. Okay, here's the 8.3 chart. Remember, this is the one that I said I think there's an error here because this should be left tail, right tail, and then two-tailed should go in between there. So this to me is very confusing. I don't really like that chart very much. So let's see how they step through this example. So step one is the original claim is that most consumers are uncomfortable with drone deliveries, and that claim can be expressed in symbolic form as P is greater than 0.5. So the number uncomfortable is greater than 0.5. Okay, the opposite of the original claim is P is less than or equal to. So this is actually our H sub O, but our claim is our H sub A. Sorry about the little spots that are kind of shining down here. Of the preceding two symbolic expressions, the expression P is greater than 0.5 does not contain the equality, so it becomes the alternative hypothesis. The null hypothesis is the statement that P equals the fixed value 0.5. We can therefore express H sub 0 or H sub naught and H sub A as follows. Okay, now we got all right, so we have a little error here. This should be the same thing as this is right here. There's a typo on this slide. Sorry about that. It should be P is less than or equal to 0.5. I should fix that, and I will try to do that. But then let's go to the next one. We're talking about the significance level. We select the alpha to be 0.05 because that's the very common one that we use a lot. Anytime we're not told what to use, we're going to use 0.05 because we are testing a claim about a population proportion. We're going to use a p-hat as our statistic that's relevant. We're going to use the sampling distribution of the standard normal because remember back in 7.1, whenever we had a p-hat that met the qualifications of having a large enough n, we were able to use the standard normal table. So we're going to do the same thing with the proportion here. And here we're going to do step 6, which is talking about getting our test statistic. When we plug in our p-hat minus our p, we get, this was our p-hat minus our p. We plug everything in. Remember, if p-hat is 0.5, then q-hat is also 0.5. Crank it all out, we get 2.55. So that is the same thing we got with the technology. And then our q there, everything looks good. So then we are continuing with the p-value, but remember we're pretending we don't have technology here, so how do we get this p-value that we saw on the technology screen? So it says because we're talking about a right-tailed test. Remember the tailed portion of your test, that decision is made by your alternative hypothesis. And remember that our alternative hypothesis was right there. P is greater than 0.5, so we have a right-tailed test. So that's what they're talking about right here. A right-tailed test. Our test statistic was 2.55. The p-value is the area to the right of our test statistic. So we go to our table, that's our standard normal table. We look up 2.55. We find the area to the left. We subtract it from 1, and we get our area to the right. So we get a p-value that goes with our test statistic of 0.0054. So we're still using the p-value method here. So we get 2.55 goes with 0.0054. And we take the p-value, and to make our decision, we compare it to our alpha. Our alpha was 0.05. Our p-value is 0.0054. That means our p-value is less than our alpha, and it appears in the tail. Okay, so basically when you're looking at it, the p-value, when our 0.05 is our alpha, and then our p-value is way over here, it's in that rejection region, isn't it? Okay, so then we're going to reject H sub O because our p-value is less than our alpha. And then we can support the alternative hypothesis. P is greater than 0.5. We conclude that there is sufficient sample evidence to support the claim that more than half of consumers are uncomfortable with drone deliveries. So now we're going to do the same thing, but we're going to use the critical value method. And step 1 through 5 are the same as we just showed in the p-value method. But now we're going to use the other method, our other decision paradigm here, using our critical value method. Step 6 says the test statistic is computed to be z is 2.55. With the critical value method, we now find the critical values. This is a right-tailed test, so the area of the critical region is the area of alpha is 0.05 in the right tail. Therefore, we're going to have how much in the left tail? We're going to have 0.95 to the left, and 0.95 to the left is going to match with a z-score of 1.645. Again, we could look at our little common critical values. Remember, this 90% confidence interval means that the alpha is 10%, but the alpha would be split into 2 tails, which would leave 5% in the right tail. And that matches a critical value of 1.645. If we went to our chart and we looked up the 0.95 would be 1.645. Here it is again. Okay, so 5% in the tail is going to be 1.645. And now we go back to our chart. And here is our graph. Here is our critical value, 1.645. Our test statistic is to the right, 2.55, which means it's in this rejection region. And we must reject H sub O. Because the test statistic does fall within the critical region, we reject the null hypothesis. Okay, so go to step 8, because we reject H sub O, which remember said P is less than or equal to 0.5. We conclude that there is sufficient sample evidence to support the claim that most, more than half, consumers are uncomfortable with drone deliveries. So, this one is something we're not going to really worry about much. Remember, the confidence interval method is not recommended. So, it's there for you, but it's just kind of discussing it. But the book doesn't really encourage you to use the confidence interval method with proportions, so we're just going to go on. Okay, so now this is something you're going to have to do. Finding the number of successes. Remember when we were dealing with our 7.1 and 7.2, we had to find the size of our sample. Given our other information, now we're going to find the number of successes, because sometimes that is not given to us. So it says, when using technology for hypothesis test of proportions, we must usually enter the sample size N and the number of successes. But in real applications, the sample proportion P hat is often given to us instead of the X. The number of successes X can be found by evaluating X equals N times P hat. So a study of sleepwalking or nocturnal wandering was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. What is the actual number of adults who have sleepwalked? So we're going to take the number of adults who have sleepwalked as 29.2% of this. So we're going to do 0.292 times the 19,136. Then we're going to round up to the nearest whole number. So 5,588 have walked. Okay? Now we're going to look at this and say, okay, we're going to do a hypothesis test using the same sleepwalking data from the previous example. Would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? Let's use a 5% significance level to test the claim that for the adult population, the proportion of those who have sleepwalked is less than 30%. Okay, so first of all, we check our requirements and make sure that we're allowed to use our standard normal distribution to model this. And we get greater than or equal to 5 and greater than or equal to 5. So we're good in both counts. Okay, step 1, we're stating our claim that P is less than 0.30. So that means that our H sub O is not our claim. Our H sub A is our claim, and our H sub O is our not our claim. Okay, so here we have stated our H sub O. Again, there's an error. Somehow I'm going to have to figure out a way to copy that there, because the slide is not copying. These are really old slides, and sometimes they don't translate very well. But this one right here should read greater than or equal to. This one is correct. Okay, so the significance level was given to us, 0.05. Because the claim involves the proportion p, the statistic is your p hat, and we're going to use our standard normal because it met all of the qualifications. Okay, so now we can use technology. We can go to our, now they're doing this with StatCrunch. We don't even have StatCrunch, so we're going to do this one with our TI. Okay, so here I have this on my screen. I entered in the pertinent data just like I did the last time, and you can see that I have a z-score of negative 2.41, and that matches what we have up here on the screen. And then I have a p-value that's given to me of 0.00796, and over here they don't give me, they give me a 0.008, which is not as accurate, but it's the same thing. And remember, to get this, I had to put in the count and the total. Here was actually the data that I put in before I entered it, because it's a p is less than 0.3. I had to move it over here. I had to put in my x, which we found out earlier in the example, my n, and then I calculated it, which I got to move here. Oops. Why isn't it doing that? I thought I was doing the right thing. And then I hit enter. And that's when I get everything there, which is exactly the same thing that we have up here. So we're able to get our z-score and our test statistic and our p-value from our technology. Then I find my test statistic using the formula in case it was not available, and notice that it is the same test statistic that I had right there. And then I have the solution for this left-tailed test. The p-value is the area to the left of the test statistic because p is less than 0.3. And then we see that we're doing the p-value is 0.008, and remember our alpha was 0.05 and 0.008 is less than 0.05, so this is in the rejection region. We're going to have to reject H sub O. Okay, so we reject the null hypothesis, and the claim was not the null hypothesis. Therefore, we support the alternative hypothesis. We therefore conclude that there is sufficient evidence to support the claim that fewer than 30% of adults have sleepwalked. Okay, so here's another example. I'm not going to go through this one. I always put more examples than you need on your PowerPoints, so you can go through this one on your own. That's 10.6. Now, this exact methods for testing claims about population proportions, I'm not going to really focus on this. I'm not going to be testing you on this. This is just talking about how to be more exact, and also they're going to talk about using a correction, okay? So a simple continuity correction, I'm just not going to test you on that at this point. So this is just talking about better methods for calculating your p-values. but for our purposes, I'm not going to be concerned with this just because we don't have enough time I want you to master the normal techniques that your calculator is going to give you and not worry so much about this one here. Okay, so we are done with 8.2, and I will be back soon with 8.3, where we will talk about hypothesis testing of the mean. And it's late, and I'm going to bed. And this is Mrs. A, and may God bless your day.